Hi everybody, this is Trig Lesson 7 on the sine law. I'm going to call mine answer key as usual. And so far, we've learned how to solve for missing sides and angles only when they are in right triangles. The tools of trigonometry that we've learned to use so far are the Pythagorean theorem, c squared equals a squared plus b squared, and the primary trig ratios, which is that acronym SOHCAHTOA, right, which means sine is opposite over hypotenuse, cos is adjacent over hypotenuse, and tan is opposite over adjacent. And these first two tools of trigonometry are only for 90-degree triangles, only for 90-degree triangles. Okay, so it has to be a triangle that shows that little box like this. Okay, the third tool of trigonometry, that's actually true for any triangle. It doesn't necessarily have to be a 90-degree angle, and that is that the three angles in a triangle add to 180 degrees. Okay, and so of course the question becomes, well, what if you don't have a 90-degree triangle? Are there any other tools that we can use? And actually, before we get into that, they show a little example here, a review example of what we did in the lessons before this. Okay, so I'm going to skip this because it's stuff from previous lessons. We will go down to learning about more tools of trigonometry. Okay, so now we will learn two more tools of trigonometry. They're actually called, excuse me, they're called the sine law and the cosine law. And today we'll do the sine law, and in the next lesson we'll do the cosine law. So these two more tools of trigonometry are the sine law and the cosine law. Okay, these are useful if you don't have a 90-degree triangle. Okay, so triangles that don't have a 90-degree angle in them, we have to use the sine law and cosine law. When using these tools, you must also have certain pieces of information. First, let's see the sine law. Yeah, so as mentioned, we'll do the sine law today, and then next lesson we will do the cosine law. So in the sine law, the sides are given lowercase letters of the angles they are opposite to. Okay, so here is angle A, and notice that the side opposite to it is little a, and here is capital angle B, and the side opposite to it is little b, and capital angle C, and the side opposite to it is little c. Okay, and in words, the sine law states that the sine of an angle divided by its opposite side is equal to the sine of any other angle divided by its side. Okay, so as shown here, like sine A divided by A should be equal to sine B divided by B, and that should equal sine C divided by C. Okay, and it says let's check this. So use a ruler and protractor to measure the following. And so if you use a protractor to measure the angles, guys, I got this: 34 degrees for this one, 88 degrees for angle B, and 58 degrees for angle C. Okay, and I did that as accurately as possible. So we're going to have some minor decimal place errors. And when I used a ruler to measure the sides, I got that side A was 3.9 centimeters, and I got side B was 7.0 centimeters, and side C is 6.0 centimeters. And so notice what happens, guys. If we go sine A divided by A, that would be this. This is 34 degrees. This is 88 degrees. And this is 58 degrees. And this little A is 3.9 centimeters. This B is equal to 7.0 centimeters. And this C is 6.0 centimeters. Okay, so if we go sine A divided by its opposite side, we would get sine of 34 degrees divided by 3.9. Okay, and so since our angle is in degrees, let's check the mode. Yes, degree is highlighted. So I'm going to go sine 34 and divide that by 3.9. And we get to 2 decimal places. Let's go 0.14. Now let's do sine B divided by B. So sine of capital B divided by its opposite side. So that will be sine 88 degrees divided by 7.0. And notice what happens when we do that. Sine 88 divided by 7.0. We get to 2 decimal places 0.14. Okay, so we're getting an accuracy to 2 decimal places, which is actually pretty good. Considering that I did the measurements with a protractor and a ruler. Okay, so there's obviously going to be some human imperfection there. And finally, we will do sine C divided by C. So this sine of 58 degrees divided by its opposite side. And so if I go sine of 58 degrees divided by 6, again to 2 decimal places, we get 0.14, okay? And so the point of this exercise is to try to convince you that these ratios are equal. So we can conclude that the ratios are equal. You can see that it holds fairly true for trying an example using protractor and ruler measurements. Okay, of course there is a nice mathematical way we can prove this theorem properly. Okay, but I just wanted to show you that example there. Okay, so since they end up being equal, you can see they're all 0.14. These 3 ratios end up being equal, and that's what the sine law is. Thus, the formula for the sine law is sine A divided by A equals sine B divided by B equals sine C divided by C. Okay? And usually when we use the sine law, guys, you don't usually have to use all 3 of the ratios. Oftentimes you just end up using 2, like for example these 2 or these 2 or perhaps the A and C ones. Okay. Alright, so let's try to use the sine law in the following example. It wants us to find AC, which is this side right here. And notice that that is across from the capital letter B, so we'll label that as little b, and that's what we want to find. And notice that we have angle A here, so across from capital A, this is going to be little a. And basically we can only use the sine law when we have what's called an angle-side relationship. When you know an angle and its opposite side, and then some other angle or some other side, then you can use the sine law. Okay, and so since we know capital A and little a, we can start off with going the formula up above here. Sine A divided by A is equal to, we are looking for little b, and we have capital B, so we're going to use these two. And we will go sine B divided by little b. And so now let's plug in our numbers. Sine of angle A is 41 degrees. Little a is 12 millimeters. Sine B, we have 82 degrees. Okay, sine of 82 degrees divided by b, and we just need to solve this little equation for b. Okay, and so if when you have one fraction equal to another, we can start with just cross multiplying, and we will get b times sine of 41 degrees equals 12 times sine 82. And then to get b by itself, notice that it's being multiplied by sine 41. I am just going to divide both sides by sine 41. And b will equal this whole big expression here. So b is equal to 12 sine 82 divided by sine 41. So how do we type that in? We go 12 sine 82 and then divide that whole thing by sine 41, close the bracket, and we get that b is 18.1, whatever it is, millimeters. Okay, so go to 1 decimal place for side lengths. All right, let's try another one. Example 2 says find DE. Okay, and notice that DE is across from capital F, so we can call that little f. Okay, and we have this capital D angle. So across from that side, this is little d, and we could say that this is little e. But you know what? I'm going to erase that because we're not trying to find little e. They want us to find from d to e, which we have labeled f. So we're looking to find this. Okay, so the catch here, guys, is if we're trying to find little letter f, we would need to know its opposite angle, which is not showing at the moment. But we know the other two angles, right? 41 and 82. And we know that angles in a triangle have to add to 180. So we can get angle f pretty easily. You just go 180 minus 82 minus 41, and we get 57 degrees. Now we're in business. Okay. Alright, so sometimes you have to kind of hopscotch your way, use all of your tools of trigonometry. So notice, where's our angle-side relationship? We have that angle and that side, so we're going to start with sine d divided by its opposite side, little d. And we're looking for small letter f, so we have to use that angle. So it equals sine f divided by little f. Okay, so you notice that it doesn't always have to be A, B, and C. Start with the angle that you know and the opposite side that you have. So sine of 41 degrees divided by 8.3 will equal sine of capital letter F, sine 57 divided by little f. And now we are in business. So what do we do? Cross multiply. And we get f sine 41 degrees equals 8.3 times sine 57. And we want to get f by itself, so divide both sides by sine 41 degrees. And f is equal to 8.3 times sine 57. Divide that by sine 41. And we get 10.6. That is going to be centimeters. Okay, and that's how you do example 2. Now, in example 3, they want us to find an angle. Find angle x. Okay, so they want us to find this. We do have its opposite side. That's great. And remember, with the sine law, you have to have what's called an angle-side relationship, which we do. We have an angle and its opposite side over here. So you have to have that, at least one of these situations happening before you can then use, we're going to then use this side to get the missing angle x. Okay, so we start off with, we know angle z and its opposite side, so I'm going to go sine z divided by little z. That's going to equal sine of x divided by its opposite side, little x. And let's plug in what we know. So it would be sine, angle z is 84 degrees, little z is 12. We are looking for angle x, so that's going to have to stay as sine x, and little x is 9. Now the way to solve this is a little bit different than when you're finding a side, because we're trying to find that angle x. And what's happening to x? The sine function is acting on it, and then we're dividing by 9. So what you do is multiply both sides by 9 first. So we're going to have 9 times sine 84 divided by 12, because that's how you multiply fractions, right? That would be 9 over 1. So the 9 multiplies on top and the 1 multiplies on the bottom, equals sine x. Okay, and remember, when you are looking for the angle and you have the ratio here on the left, what you have to do is you have to do sine inverse. So we would have to go sine inverse of all of that junk over there. Okay, or if you want, we could go like this. Let's work out that number. 9 sine 84 divided by 12, and we get 0.745. Okay, but we don't want to lose all those decimal places, right? I don't want to cut off any decimal places, because then we won't get a very accurate answer, or the most accurate answer. So we want to try to keep all those decimal places. So down here then we would say x is sine inverse of 0.745 and all those decimal places. Okay, and the way to do that is you go second function sine to get sine inverse, and I want that last answer in there. I want the 0.745 with all the decimal places. And so you see the word answer, ANS, is underneath this negative sign on the calculator. So I go second function negative sign and it puts in the word answer. So it's going to put that whole answer into my sine inverse function, and it will give me an angle of 48 degrees. Boom. All right, let's finish off with an application example. It says hole number 6 at the Kenosee Lake Golf Course is straight from tee box to green. Anthony hit his tee shot 265 yards, but 15 degrees off the path to the green. If he hits his next shot so that it approaches the hole at an angle of 23 degrees with a straight line path, he will be on target to sink the shot. How far must he hit the ball to make the shot? Okay. So his initial shot was along here, and it wants to know how far is he going to have to hit the ball along this way to sink it right there on the green. Okay. So we do have an angle-side relationship, this angle and its opposite side. So we could call this A and this little a. And we do want to figure out this little b distance here. Okay, and the angle across from it is this one, so we could call that b, getting back to our traditional letters for the sine law. So you would go sine A divided by A is equal to sine B divided by B. What's angle A? 23 degrees. Divided by little a is 265. And then we would have sine B, sine of 15 degrees, divided by, we are looking for little b, okay, the distance that he's going to have to hit the ball to make the shot. Okay, so we're solving for little b, and this is the sort of easier case. You just cross multiply, and we get b sine 23 degrees equals 265 sine 15. Divide both sides by sine 23. And so b is equal to 265 times sine 15, and then divide that by sine 23, and we get 175.5. 175.5 yards. Okay, so that's how far he must hit the ball to make the shot. Oh, it does say answer to the nearest yard. So 176 yards. All right, so there's Trig Lesson 7, everybody, on the sine law. Here's the assignment as usual, so try these questions, make sure you can do them, and pretty sure there is an answer key at the end here. Yep, there's an answer key, so you can check your answers, and as usual, I will do a video showing homework solutions and send it to you later in the week. All right, everyone, I hope you're doing well. And yeah, keep working on our work. We only have, I think, just 2 more lessons left in trigonometry. And then I can send you a unit test that you can do open book and send back to me. Okay, everyone, take care. I will talk to you soon.